Okay, we're about to do something complex here. So I created an array list of employees and I populated it with one employee, just so we have something complex that we can use to put in our shared preferences. Okay, so to be able to do this, I'm going to have to obviously create a JSON guy, right? So I'm just going to call mine G is equal to new JSON. And of course, it's going to have to import the guy. Okay, so cool. Now I've got this guy. So now what I want to basically do is to create a string that contains this guy, all right? So this is a little weird. So string, I don't know, my I don't want to call it the same thing. Imp list string? Okay, something like that. And so what I'm basically doing is I'm calling the JSON guy and telling it to go to JSON, and then I give it my object, and I just give it the thing that I want, which is imp list. And it can figure it out on its own. That's the whole point of going to get one of these libraries. You just say, go to JSON, and presto changeo, it does. Hey, just for grins, let's display what this thing looks like before we put it into the guy, okay? So let me go back to my main activity here, and let's add something. Let's add a multi-line so I can see what this guy looks like. So I'm going to grab me a multi-line. I'm going to drop him in here. Cool. And let's just call him edit text display, like we kind of do in the past. Okay, cool. Let's go back to my guy. And I guess I'll need to go, doggone it, I need to go here and do this. et display. Then I'll have to go here and get this guy, just like we've done all these before. Et display is equal to find you by ID. r.id dot et display. Cool. All right. Now, all I want to do is, before we put this in there, I want to see what this JSON thing does. So let's do et display set text to imp list string, and let's go see what this guy looks like, because I'm kind of curious. Okay, so it's no longer other activity, but it spits this thing out. And it's got some really cool, it's got angle bracket, it's got square brackets, and it's got all this stuff, and blah, 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 blah. And it can figure it out, okay? It doesn't matter if we can figure it out, but isn't that pretty cool? It just textualizes, how's that for a good term? It takes a complex object like an array list and puts it into text, which is exactly what we want. And then afterwards, after I got it into text, well then doggone it, it's pretty doggone easy to put it into my guy. I just go in here to my editor, and just like I did before, right? I did editor dot put string, right? No big deal. So imp list string. So now I've created a text version of this thing. Oh, I do need to give it a tag. Let's just call it list, since I'm... All right, something like that. All right, so this makes it a heck of a lot easier to be able to create something, take something complex and create text out of it, send it down to storage, and then when I want it back, I do the exact same thing over again, where I pull it up instead of to JSON, it's going to be from JSON, and it'll automatically repopulate everything back the way it was. So this is a very common technique for serialization. You probably need to learn JSON. All right. So let's just do a review of the state management things, because there's a lot going on. Bundle. Bundle is used internally, like when the phase changes. So like during device rotation. So bundle is held in memory and is passed back and forth between activities after they get created or destroyed after like device rotation or somebody hid, or all those other kind of things. The intent guy is how to pass data back and forth between other activities. I want to launch a browser, but I want to tell what URL to go to. Or I want to launch a screen and I want to remember the name that I put in there. Either way, those guys, it's in memory and it's just passed on between different activities. And then shared preferences, which is not at all like the other two. Shared preferences is I want to shut my guy completely down and bring him back up and have him remember something. So it is stored, it is persisted onto storage somewhere. I keep saying the word disk, but you guys know what I mean. Okay. Whew. On page 434, they actually talk about JSON a great deal, but to tell you the truth, I'm not going to go in that. I would much prefer you would use the JSON library. It is a lot more sophisticated and a lot easier to use. And so rather than learning the tough way to do it, I just showed you the easy way to do it. Cool? All right. And now we're ready to change topics completely and talk about exceptions on page 434. Now we've been dancing around not using exceptions for quite some time, so this is kind of sort of important. Hopefully, this is all a review from when you took the Java class, but if not, we're going to go through it from the beginning. All right, so generally speaking, when you're writing a computer language, you have some choices on how to do exceptions. One way is what's called a resumption model, where an error occurs and then you deal with it or not, and then the flow goes directly to the next line in place. So you're running along doing something, and the fourth one has a problem, and then okay, fine, you deal with it, and then it goes to the fifth line, the sixth line. Okay, that is not at all how most modern languages do it. Most modern languages now have a different thing called a termination model, which means once you get to that point, flow runs off to some other process that handles the exception, and you don't ever have a way back. It's a one-way transfer. Oops, you got an exception, we're going to go over here, we're going to handle the exception, and when we're done, you're not getting back. There's no way to get back to where you were. So it's kind of sort of important to understand how that works. So flow just completely stops. You're running along, exception, boom. Nothing else below that point ever is going to run. There's another term that they use called structured event handling. And what that means is instead of having a single event that can handle this thing, when I write an event handler, an exception handler, then I can be very specific. I can say, oh no, I want this one particular error to be handled this way, this one to handle this way. So for example, if I'm trying to open a file, and so there's a lot of things could go wrong, like the file does not exist. I want to handle that one way. The folder that it's in doesn't exist. I want to handle that way. It's read-only, and I want to handle a separate way. So structured means I have multiple choices for how the exception is handled. I could just wrap them all together and say, to heck with it. I couldn't open the file and I don't know why. Or you could go into very specific and say, I know precisely why you couldn't open the file, because you misspelled it or something. Okay. So in the real world, let me get up to here. It doesn't really matter where. So I use try and then a catch statement. Now here's where you can have the structured guy. I can go in here and I can have a particular type of exception. So I'm just going to put in empty stack exception, okay? And I'm going to call that one ESX, just for empty. And then I can have another one. This is, well, okay, if it's that, I want you to handle it. Otherwise, if it's something else, I can just kind of keep going. So let's go, I don't know, into file exception. So this would be EOFEX or something. And see how you could just keep stacking these guys? How come I don't like that? Oh well. Or at the end, you could just say, no, I'll take all exceptions. So exception here is just like the if I'm doing something, I can have a very specific exception, or I'll just take them all. Now, it's very important to put these in the correct order, because it's like a filter. When the exception occurs, it's going to go down the list and hit the first one that matches. So if you put the most generic one at the top, well, then the more specific ones will never run. Okay, so the order of these catch statements is kind of sort of important. Okay, And then there's a next thing in here called finally. Now finally is pretty cool because what that basically means is regardless of whether or not I had an exception, I want this code in line 47, whatever that is, to run. Okay, so exception occurs on line 35. Either line 37 or line 41 is going to pick it up, one of the two. And then after that, the finally is going to run every single time. Okay. So, here's like we're doing something dangerous, whatever it is. You know, like I'm dividing by 0 or something. I don't know, whatever. Doing something that could have an exception. And then I have two different filters. One that says if it's an empty stack, or if it's anything else, any exception, that I'll take it from there. Okay. Now the thing about this is this may or may not create an exception, but this always runs. Okay? Okay, so let's just talk about the rules for just a minute. There can only be one try block. And there can only be one finally block. But you can have an awful lot of catches, okay? Lots of catch statements. The order of the catch statements do matter because the more it's going to hit the one in order, and the first one it matches, it's going to take. So if you've got these things in the wrong order, they're just not going to work. And then the finally, that block runs regardless of whether or not you have an exception. So it doesn't matter if you had an exception or not, it's always going to run there. Okay, cool. Now, why would I want to deliberately cause an exception? Well, you do that for lots of reasons. In our example of the employee class, I'm going to bring up this employee guy. So this is the one from Chapter 11. Okay, and so whenever there was an error, like here, the name either was null or empty, I just put it out to a log, which is not necessarily the way we should do. What we probably should do is we should probably throw an exception here. Okay, deliberately throw an exception. This is the technique I want you to do. So instead of doing log, what I'm going to do is I'm going to go in here and change this, and I'm going to say, I want to throw a new exception. Hey, is this an example of an anonymous class? Why, yes it is. Because I don't give this guy a name, because I don't need to know the name. So, this is a technique that we could use to go in here and say, throw a new exception, whatever. All right. So I've got a red squiggly here. What on earth does that mean? If you hover over it, come on, hover. Come on. It says unhandled exception. So what I probably need to do is I need to go in here and tell it somehow where this thing is actually taking place. So if I have a method that throws an exception, I either need to handle it right then and there or inform the method that somebody else is responsible. And that's what I want to do here. I want to go here and say throws exception. Okay, now let me just go through that one more time. I'm throwing an exception on line 59, but I have a choice. I need to handle it myself, which is not what I want to do, or inform the people who are going to be using my employee class that they have to handle it. That's what I want to do. I want to tell the other guy, it's your responsibility to handle exceptions. Okay, we're coming up on the 15-minute mark, as usual.